Hi, my name is Vinay. I am a technical lead and manager at Aurora. So Aurora is a company that builds a self-driving vehicle. Cool. Okay, there we go. The slides. So today we're going to actually talk about how Aurora is using Kubeflow Pipelines to accelerate building basically our models for our autonomous vehicle. Cool. Next slide. Yeah, we can just jump to the agenda then.
Yeah, I'm just trying to make this full screen.
Okay.
There we go.
Cool. So we'll do a little introduction about Aurora, and then we'll jump into talking about Aurora's perception system. And then we'll talk about how we're using Kubeflow at Aurora, and finally, how we've adopted Kubeflow at the org. Next slide. So I mentioned Aurora, we're focused on self-driving vehicle. Our mission is to deliver the benefits of self-driving technology safely, broadly, and quickly. So we're actually building a driver that can work both on semi-trucks that are freight hauling and also passenger vehicles. Of course, we're hiring. So if you're interested, you can go to aurora.tech. I want to actually kind of call out, if you look at the top of both vehicles, you can kind of see a bar. That bar actually is a set of sensors, and those sensors form basically the basis of our perception system. Next slide. And next slide. And basically the perception system is basically the start of the autonomy loop, right? So the Aurora driver has a couple of critical things. It must understand the environment it's in. It must then reason about that environment. It then must make decisions on what action to take, and then finally execute them. Like, this is a video, but in essence, you can see that from the still, what's happening is that the truck is driving on a highway. It's actually in Texas, and it's actually detecting the entire environment around it. And basically that sensor suite basically is looking at things, and then we're actually able to draw bounding boxes. And all of this is actually powered by deep learning. Next slide. And at Aurora, our perception system has 3 core models that is part of the, so we first, on the left here is sensor to tensor. It basically is a detection engine. On the right, we have something called sensor to adjustment, which we call our recurrent tracker. And at the bottom is called REMX. So it's like a remainder explainer. So everything else in this environment is explained away by that. And then we add in our persistence engine in the middle, and that's actually forms the basis to then provide that information to the next module. Next slide. And we're going to actually focus on sensor to tensor today. And this is actually where our Kubeflow journey actually started. And sensor to tensor uses multiple sensor modalities. Next slide. And those modalities are LiDAR, radar, and HD maps. And we also actually have camera as well. And the way that we go about this is, well, one interesting thing is when you have all these sensor modalities, each of them is in a different resolution and a different view. And basically the reason we need sensor to tensor is we need to take all of these resolutions views and basically convert them into one representation that we can then run detection on. Next slide. And we actually call basically S2T our neural convolutional engine. And what happens here is that in the upper left-hand corner, we're going to basically take LiDAR, radar, and HD maps and convert that to what we call a Euclidean intermediate view. At the bottom, we're actually combining radar, and you can actually kind of see a little bit of a green on the car. That's actually velocity. So we use radar, and then plus the velocity and plus the cameras from multiple angles. And then again, we have to actually convert this to a Euclidean intermediate view. And then we combine both of those things and come out at the end with 3D bounding boxes, velocity, and uncertainty. Next slide. And once we have combined all of this, this enables the Aurora driver to actually detect the environment around it. And here you can see there's the Aurora driver is working in multiple different places. And it's actually fundamentally what's happening is the truck is actually driving the real world. It's making decisions, and we're actually also collecting data. Next slide. So what happens is that once our vehicle is in the real world, like you saw in the examples, we're actually collecting data. That's what we call on board. So that's in the real world. And then we actually have a log inside of the vehicle. Once the mission is done, we come back to home base and we'll actually upload that log. And that's actually where the offboard journey begins. And that offboard journey is really a data engine that is actually powering the autonomous vehicle development, because we take an ingested log, we pass it through multiple labeling systems, and that's actually where Kubeflow Pipelines kicks in. So we are able to take the labels and then start training, evaluating, and then finally simulating to actually test if the new model is doing well. If it's doing well, we then redeploy that, and then it goes back out into the field. And then this actually forms our entire loop to do autonomous development. This is one of the most important workflows at Aurora. Next slide. So At Aurora, we have chosen Kubeflow Pipelines as our main ML orchestration engine. Our pipelines contain high-level steps for training and evaluating models and preparing it for deployment. We actually, with those pipelines, we have multiple triggers. The point of those triggers is so that we can simplify and make it easier for people to train workflows and do that more frequently. So once a trigger happens, we go through a build layer because we build a bunch of Docker images. With those Docker images, we then send them with the parameters up to Kubeflow Pipelines, and then that's when model training begins. And when the training begins, we actually use Kubeflow as a high-level orchestration engine because underneath that, we actually have different ways of basically using compute. Most like our jobs go on something called Batch API, which is our own internal batch processing system. We use AWS SageMaker for training. And finally, there are some jobs that directly just go on Kubernetes. And under the hood, because we've built these pipelines, it enables us to handle artifact tracking, which enables reproducibility. Next slide. So the way we compose our pipelines is actually through using a set of components. As I said, we use Batch API, which is our internal batch processing system. SageMaker, we have a couple of custom components, and also we do job notifications via Slack. And actually, let's, next slide, we're gonna dig into some of these components. As I mentioned, Batch API is our batch processing workload system. It's actually intended for compute-heavy workloads. And in Batch API, we have two critical concepts. One is a job, and we have tasks. So jobs are composed of set of tasks. They have interdependencies between them. And these tasks can range from thousands to tens of thousands or millions. And the reason that we have basically such a fine-grained DAG is that we want developers to actually have small tasks. So imagine we have a big, huge set of logs. We want them to break them up into small sets and then basically reprocess them and come out with some other output. When you have a small set of tasks, if one or two things fail, it's really easy to see what went wrong, and it becomes really cheap to rerun them. So this is why what we do is we actually connect Kubeflow pipelines to connect to this fine-grained DAG system, and then we basically will kick off jobs for dataset generation, model evaluation, and also simulation jobs of the vehicle. And as we're building pipelines, we work with teams and we start to build custom components per job. So each job actually has a different set of parameters that become Kubeflow inputs, and then each job will have a set of outputs, which are also Kubeflow out. We need that for model tracking, basically. And basically, there's this minimum level of work that's required to create a Kubeflow component. Generally, when we have a pipeline that's already production, it's getting ready to be consistently used, we'll make that investment for those components. There is this other kind of gray zone where a team may be trying Kubeflow, and they're like, well, we don't really want to build out all these components. For my jobs, can we just have something to launch it? So we have a generic one that basically will just let you do a wait or launch and wait. And it's just all about reducing that initial development input time. But in the reality, the thing is that it's better to have these custom components because it's more semantically meaningful. Next slide. Once these batch API jobs are done in Kubeflow, the next step is SageMaker. So we use SageMaker to launch multi-GPU training instances that have optimized networking. This kind of is a solved infrastructure problem for us. So we just pull in whatever SageMaker machine and have it run. And the way we connect SageMaker or Kubeflow to SageMaker is actually, we use the open source component, but we've actually wrapped a lot of the parameters because there's literally at least 50 or 60, and it's really a little bit more complex than most users want to deal with. And one interesting thing that we've had to do with our integration with SageMaker is we actually inject another training wrapper that's considered our main, because as we started working with teams, we realized that they actually already had training binaries that were basically just scripts that take in, command line args. So they already have a process, they already have this training script. And we had to connect that to a SageMaker job. So we added another main, and we just basically piped through the hyperparameters, all of their command line arguments. And this kind of is a little bit of a hack, but unfortunately, this is the way we had to kind of integrate these two systems together. And I guess one area that we're still kind of working on refinement is component output, because SageMaker kind of just gives us one, the component by default gives us one output, which is the folder, but we really actually want the exact model path. And that's one small thing we need to handle. So as these training jobs are running, we connect these to AWS services. Specifically for storage, we use S3. So we're reading data from S3, and we're also storing the model there. And this is a little bit of a divergence from using generally from Kubeflow's artifact system. And the primary reason is because we actually have multiple teams. They have their own ACLs that they need to implement. And also they have their own lifecycle policies, and a one bucket doesn't really fit them all. So we've kind of actually had to split up each of the teams to have their own buckets. It's kind of like bring your own bucket with your own policies. And coupled with that, we actually utilize SageMaker's CloudWatch logging integration and process monitoring. So those kind of pieces are just right there, and users will use the AWS console if they really want to know something about their job specifically. And finally, as the training job is running, we connect it to TensorBoard, and we directly use the Kubeflow TensorBoard integration in pipelines. And basically, users are using that to visualize their metrics or error curves as they're going along. Once the SageMaker job is done, next slide. A couple of our pipelines have actually started to use a component to comment back to their PR. So basically, as the job finishes, the pipeline will comment to their GitHub PR. And the reason we do this is because we want to link a given pull request directly to a one or more Kubeflow runs so that reviewers can then click in and find details. And some of these pipelines actually post some of the critical metrics for the model back to the PR. And also they post some summary data so that the reviewer has a quick set of details that's right available in the PR for them. Another kind of interesting thing is that one pipeline has actually posted a review criteria and landing checklist onto the PR. This is intended to remind reviewers exactly what they're supposed to do when they look at the PR, and to also for the person who is created this run to check off that they did certain things. And these are kind of more subjective review criterion, and it is kind of like a reminder, hey, this is what you have to do. And finally, one of our pipelines also posts back to the PR a set of GitHub PR commands that will enable them to promote their model from experimental to production. And basically, when you run that command, it actually does a config change. And this is kind of like a self-documentation thing. It's like, hey, you're done. You're about to land. By the way, you can run this thing and promote it to prod if you want. And it's like just a way that we can make it easy for potentially either new developers to know how to train this model, or for another developer from a different team who may be running this model, like exactly how to do stuff. Next slide. And once that component is finished, the next one we do is we actually send messages to people about what happened with their run. So basically we have a component, it just sends a Slack message to you. And it sounds really simple, but surprisingly, it's like one of the most used components, because generally for the workflow, people will kick off a bunch of stuff and they just want to know when it's done, because it's not deterministic exactly when it's going to finish. So they want to know when it's done so they can come back and look at stuff. We also generally include like a message about success or failure. If sometimes we also want to know what failed, because that's kind of the burning question, especially it's the middle of the night and you get the message and someone's like, well, what happened, right? It failed. And another kind of interesting aspect is that users have asked us, hey, can you actually give me some of the outputs from the components? Because I actually want to have those pieces of information right away. And I actually also want to have logs of the component that failed so that they can just kind of, it's an ease of mind thing, like, oh, it failed, let me know what happened. Yeah, as I mentioned, this is one of the most used components at Aurora, surprisingly. Cool, next slide. And putting all of this together, this kind of ties us back to the start, which is we actually have a core pipeline for our S2T model, whereas we're training on SageMaker with the TensorBoard. Then we actually do a number of exporting steps on multiple GPU SKUs using the NVIDIA TensorRT SDK. And then after that, we evaluate the model and publish some metrics. And this core pipeline was one of the first pipelines to be built at Aurora. We've actually expanded on that, next slide, to a much larger pipeline. And it might be a little bit hard to see, but basically this thing also has data set generation, and it has a couple of more evaluation / what we call calibration steps. The reality is this pipeline of work used to take weeks for an ML engineer at Aurora to go through. And it is pretty complex and there's a lot of things to do, but literally it would take weeks for them to work through this, because you would have to run at least 5 or 6 scripts if I'm not forgetting. And now most of this is captured by the pipeline. This has taken what used to take ML engineers weeks to do. Now it only takes 1 week. Primarily driven by the fact some of these steps literally do take like days to run, but regardless, it is like zero touch for ML engineers. Next slide. The benefits that So with this pipeline in place, what we've actually done is to figure out kind of the developer workflow. And we launch these pipelines in 3 ways. One is by the CLI. So basically either we use Bazel or a wrapper script to kick off the pipeline. Then we also have PR commands that you can basically type /Kubeflow train and you type a model name and it'll kick off a pipeline run from that PR. And we kind of use this actually for like basically kicking off training as like an integration test for a related PR. And then finally, we have CI/CD. So we actually have models that now are trained either daily or weekly on a sanity set to ensure that our critical, pipelines are functional. And the way with these triggers in place, the way that developers usually launch this stuff is they launch a whole bunch of stuff off, and then they wait to get Slack notifications to come back to check which model is the best. Next slide. And the benefits that we've seen in the organization, first and foremost, is automating the ML lifecycle. It just reduces a whole bunch of manual steps that users had to do to train models. And this has been, really awesome for folks. And it's increased our iteration time. As I said, we used to take literally weeks to land S2T. Now it can be done in a week. Not only that, S2T has now a consistency of landing at least twice a month. That is a big, huge organizational change. And that really, as I mentioned, this is one of the most critical components of our perception system. And it is moving, the company forward and reduces a lot of busy work for that team so they can actually spend time doing other stuff. And another aspect that we really, wanted to see was collaboration. Kubeflow is naturally, is fundamentally a web app, and you can share links in Slack. And this has enabled ML engineers to share their runs and let other people see metrics, tensor boards, and results super easy. This is like really nice for folks because it's just an easy way to let them know, hey, I'm working on something, or hey, this is done. Can someone take a look? And with these runs, we are actually now starting to build out strong lineage because we actually have a safety case that kind of shows why our vehicle is safe and what we've done. And now we can easily track basically the metadata related to a model, which included ingested logs, training parameters, and actually also the code changes that went in with that model. Finally, the other benefit is we're abstracting cloud infrastructure. ML engineers don't really want to know anything about this kind of stuff as it relates to auth, networking, and whatever else. With the pipelines, we're able to really kind of take away what we used to do from a laptop and kicking off stuff and abstract all of that launching code into the cloud. And that means that the laptop is kind of less important in what authentication, what user role, it has. And this makes it so much easier for ML engineers. And finally, interesting enough, infrastructure engineers now can also launch training because we also make changes all the time and we sometimes never know what would happen to a certain workflow. And now because we have PR commands, it's like a really simple thing. It's like, hey, this might affect these jobs. Can you just run those PR commands and find out if that pipeline still works with your infrastructure change? Cool. And next slide. And the way we've actually gone about adopting this in Aurora is first and foremost, we figured out the adoption path is you give people resources and you do white glove service, because generally those teams will say this automation is not their primary goal, nor is it their like big product feature they need to land. So they're not going to prioritize that work. So what we found is that basically we have to work with teams or provide them help to directly build those pipelines. And once we've built those pipelines, what we do is we also then pitch other teams by doing internal demos, showcases, and then has started to spark interest from other teams. Be like, wow, that looks simpler. That's a lot easier. And as we've gone around building the pipelines, I think we've realized one other thing is that you have to build the pipelines in small increments to show value. And by building those small pieces, people can see basically how steps are coming together. And then kind of an interesting is we've noticed that some ML engineer will tell us, well, I actually don't know how to make this a step. This is like just each person kind of has their own way of evaluating and running post-model evaluation steps. And the thing is that once they see the pipeline in front of them, they actually start to realize, hey, this portion of my workflow could be automated. I could have a step for it. And they actually will be like, well, let me just put that in because that saves me time. And it's all about building that small pieces and letting them come and figuring out, hey, what other steps do we need to add to this to basically consider this an end-to-end workflow? Cool, next slide. And in terms of kind of how we've adopted this across the organization, we actually started in maybe mid to early 2021. And this is going from October to now. And basically before it was just a small set of people running it. And now basically, we've seen significant increases of usage. And yes, there is a spike in June. And that's because we had interns who were smashing on the pipelines. Well, I guess that actually relates to another thing is that we did realize that bringing on new folks, especially from school, all of this is a lot for them because they barely know Docker. And then they're like, I don't know what Kubernetes is. I don't know what SageMaker is. And I don't know what Kubeflow is. And like, basically we had like, I had an intern on my team building a pipeline, and that's basically, it's probably like 100 something plus of just him trying stuff. And that's actually one area that we still need to maybe work on is like documentation, because we have someone like that who's really fresh. There's a lot to take in, and and basically, yeah, it's a lot for them to take in. And now that we've had we have like a number of pipelines across our organization in place, we have actually very consistent usage. Next slide. And the other stat we really care about is like monthly active users. For us, it's like we have like 15, 20 plus users every single month, and this is growing as we continue to build out pipelines and swap workflows from shell scripts to basically Kubeflow pipelines. Cool. Next slide, and I think we're done. Oh, actually, no, never mind. We do have one more slide. I think this is actually the more important stat for us, which is average runs per user, and it's close to 20, which means, if you kind of average it out, it's like basically every single developer launches 20 runs a month, which means every single day they're running at least one, but in reality that they're launching like 3 or 4 in 1 week. And they're consistently doing that week over week as they have feature work. And that, for us, this is what really actually matters more than anything else. Cool. Next slide. And I think we're actually, yeah, is there any questions? Yes.
I have a question. Thanks a lot. It was very interesting. Do you have a mono repo to handle all this, or how?
Yes.
How is it managed?
Yes, we have a mono repo, and that's actually why in the couple of slides behind, we have the Docker image building step. The thing is that everything is in the repo because we use Bazel, and basically what has to happen is that we have to take all the source and basically build out each of those Docker images and then plumb that into the pipeline. And this kind of runs a little bit against kind of how generally some of these like open source workflow orchestration tools work. We actually don't use a base image. We actually have a very minimal base image, and we basically build everything from the repo so we can have full hermeticy. Like that includes Python deps, C++ deps, and then we link everything to, some stuff gets linked together, and then we also produce like a hermetic binary that gets stuck into an image. So each commit should be able to be fully reproducible. Yes.
So Aurora is taking a lot of data sources from multiple areas, right? You're testing a lot of data, you're training the model, building the pipelines. Where is some of the areas of friction you can now reduce? Is it some of the customization? Is it the actual work with the wrapper with SageMaker? What are some of the things that you can get in terms of faster? Because you have competitors who are trying to learn quickly and improve the algorithm.
Yeah, I mean, for us, it's the speed. This is the number of times we can do training. Basically, before, when we used to do training, there was actually a set of folks who would hear about a new label set, either through email or Slack, and then they would train it on their own time, like when they had time. Now, since this is an easy trigger via API, we're actually going to start building, like when we have new labels, we're going to be able to train immediately. Or B, the other option is to do like basically continuous training weekly. And that actually has benefited a couple of teams because they'll swoop in the new labels plus potentially any new code changes. And that gives them a health of whether new data is actually moving the model in the right direction.
Is Batch API custom, and if it is, why didn't you just use Spark or Dask or one of the other tools?
Well, the reason we actually didn't use Spark and we actually do use multiple frameworks, but Batch API, the main reason we did is because we found that actually, over the years that Spark is kind of expensive in the sense that actually the data scheduler that you get initially is, yes, it does work, but then you start tuning it like crazy. And then also the JVM uses tons of memory. And Batch API is basically mostly written all in Go. And it's basically really a simple interface between the user. It's just, hey, launch this process, and then you have a massive DAG. Yes, what does that mean? That yes, users do actually have to write a little bit of their own data scheduler, AKA they take in their input, split it up, and then basically handle data input output per step. But because that the users are taking on that work, we found that basically we don't have to deal with the Spark scheduler at all. and we don't have to deal with all the JVM memory outages, and it's kind of like the user code that is kind of responsible for their own memory usage. I mean, there's actually a huge blog post that we wrote about, like a multiple series of blog posts that also explain a couple of other interesting critical features that differentiate why we use Batch API. In particular, like we have the ability to retry tasks, and those tasks can actually increase in memory usage as well. So you can have a worker of a fixed size, but then every single subsequent try you could have a different set of resources with different levels of isolation. And also, we also integrate concepts of where your task can go, aka you can say, I'm fine to have spot. No, I need on demand. I'm open to all. And this is actually why we say for us, it's like massive cost savings, because we give a basic set of levers to people, and we kind of expanded upon that as we've worked with customers.
Vinay, thank you so much.
Cool. Thank you to Ricto and DCube for making the summit happen, and of course Amber and Josh for putting this on. It's really, it's awesome that we're getting together and having an opportunity to meet everyone. Thanks.
Yeah, I would like to highlight that Vinay does show up to the working group meetings. He provides a lot of input. And this is a very strong example of a great user for the Kubeflow community. So thank you for the contributions that you've provided.